Batarya Teknolojilerinin Geleceğini konuşacağız. Aslında sabahtan beri farklı panellerde, içeriklerde paylaşıldı. Mobilitenin kalbinde batarya var. Bataryanın da en kritik noktası kritik materyaller ve buna kimin sahip olduğu. Dolayısıyla aslında teknolojik gelişimler, batarya konuştuğumuz zaman jeopolitik noktadan başlıyor. Yani kritik materyaller kimin elinde ve nasıl yönetiliyor? Ben açıkçası hem Avrupa'da hem de Amerika'da eş zamanlı yatırım sürecinde olan iki farklı batarya şirketinin yatırım süreçlerinde yer almış birisi olarak Çin'le Amerika'nın veya Avrupa'nın gerçekten batarya teknolojileri konusunda rekabet tarafında biraz zorlanacağını düşünüyorum. Ama bütün bunları gelin konunun uzmanıyla değerlendirelim. Şimdi sahneye Richard Bouvert'ı davet ediyorum. Richard. Welcome. Welcome. The floor is yours.
Thank you. So, very happy to be there today to speak about battery. Everyone is every day hearing battery, 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 and me even more because I'm inside. But I'm there just to share with you 15 years of experience in the battery, and not just designing battery, but manufacturing battery, doing battery, integrating battery into vehicles. And on top of that, today I will speak and introduce the solid-state battery. You will think that, what is a solid state? And there, when you can read, you can see that I would like to speak about the future of the technology. Obviously, because when you think battery, the future is not the battery of today. You know, and all the time I like to share with you that all of you, you have a phone in your pocket or in your hand. And inside you have a very, very, I would say, high-tech battery inside, but this is a battery that we call liquid battery. And I will explain to you what is a liquid battery. There is a drawing that is simplified for engineers, but I will make it even more simple, okay? Just keep in mind what is a battery. It's very basic what I will say, but if you understand that, you will understand what is a battery. Imagine three components. A battery is done of three components. One electrode that is positive, one electrode that is negative, and on the middle, one electrolyte. And what is the difference between a solid state and a liquid battery, what we call lithium-ion, is that the electrolyte is liquid and the other is solid. Okay? It seems quite simple. Yes, it is. But to manufacture a solid-state battery, it's not really the same. Because when you have different components like electrodes, what will be the quality of the battery will be the interface between the three bodies, the plus, the electrolyte, and the minus. And when it's solid, you need to be sure that they are all touching each other perfectly. When it's a liquid, obviously, it's not the same story, it's quite easy. So when we think about technology, and we, you know, as the Blue Solutions, we are developing the Gen 4. It's already near 15 years that we are manufacturing in two continents, in France and in Canada, the solid-state battery. And that we are using those batteries on vehicles in different parts of the world. In Europe, in Africa, in Australia, in US. And what we can see here in this graphic, just try to see, we are talking about energy density. Energy density. This is what is driving the world of the battery, energy density, because at the end, this is the autonomy. And energy density is all the time calculated with energy per kilogram or energy per liter, because sometimes on some vehicles, you can carry a lot of weight, but you need big autonomy. And in other vehicles, you don't have space to put your battery. So you need to have the battery that is very small, but allow you to drive many kilometers. So obviously, we have a lot of technology inside the battery. You have, I would say, the technology on the product, on the battery itself. You need to learn more or less whatever exists in the engineering in the world. You need to have people that work with you that are or engineer or PhD that spend their life in the science and work on that. And I can tell you, it's 30 years I'm in the automotive industry. I'm engineer from a nuclear, and I can tell you it's a very, very serious matter to do it. So you need to learn a lot of things for the product. For the manufacturing, it's even worse. Maybe you have heard that some company in Europe have failed. You have heard maybe about Nordvolt, but it's not the only one. This is the one that you have heard because it's a very big one. It's a giant that failed. Failed because they were not able to manufacture the product. They were spending millions, and at the end of the gigafactory, the first line, they were producing few cells, and you cannot live like that. So that is very important. But on top of that, you need to be able to produce, I would say, those very, very precise product, and you need to be able to, I would say, integrate that inside the vehicle. It could be a truck, a car, a two-wheelers, a robot, a drone, whatever you want, but you need to put that inside. And people forgot that the battery is a life element, and you need to be able to pilot that. So you need to have a very strong knowledge in software. Of course, AI is coming there because it helps us to really drive the system and to learn in the same time. And there is a lot of science there. And it's not exhaustive, in fact. So it means when you do battery, you need to drive a bunch of ladies and gentlemen that are crazy of science, scientific, that spend their time in I would say, in labs, but also that are able to do prototype, clearly. And that this is a very different world. So today I will focus more the presentation on battery linked to the automotive, because at the end it's clear that automotive is driving the world of the electrifications. Whatever we can do on the QCD, on the quality, on the cost, and on the time to market, this is where we are the best in the world. Automotive is the most stringent, the most difficult, the most challenging world in the industry. And if you are able to succeed in the automotive industry, then you will succeed for all the other markets. It's quite obvious. And this is what I'm asking the customer, by the way. When you talk to them, when I'm talking to Airbus, they ask me, are you okay with the automotive? Is your product validated by some OEMs, by automotive? Otherwise, they will not use it. It's all the time the point of reference. So there are a few data there, and on the middle I put few words, but I will come back on that, because I really think that the success of producing battery has changed. We have heard today about the leader. The world is Chinese today. The world is Chinese. It's Asia. It's clear. If you want to buy a battery today, you will buy a battery that is coming from Asia, and most probably from China. Okay? Why? Because they start in 2010, 2011 with a lot of incentives from the government, a bench of very good scientists, because in China the reservoir of talent you cannot compare with anywhere in the world. Okay? And the level of knowledge is very high. And also they have, I would say, no limitation how to build a factory for space, for permitting, and so on. So it was very easy to do. In China, to make I would say, battery plant, it's 2 years. I would say that in Europe, if you have the best of the best team and half of them Chinese, you will take 5 years. And I would say that your payback will be 15 years. In the meantime, you will spend billions. Billions. I'm talking in euro or dollars, whatever you want. So it's very important to have that on mind, to keep that and to know that the figures are extreme. Battery, this is one extreme world. And battery, this is very strange, because for the people who work in mining, it takes more or less 15 years to identify and start a mine. And after, you have to wait basically 10 years to get the payback. So it means 25 years, a quarter of a century to get your payback. Battery is not so far. That's why so many people are hesitating today, and that's why I will share with you the vision. What has changed? If we want to scale up factory, even today, of solid state in China, but as well, I would say, in Europe or in US, what we should avoid as a mistake. And that it's something clear. The market, forecast, there is one truth, Forecasts are all the time wrong, but we need to see what will happen, And when you compute, when you look, all the people that are doing forecasts on battery, we reach on those figures. And there, what I asked to my team to give some information about the size, market size, because beyond the terawatt hour, that does not mean for many of you, there is dollars or euros in terms of business. And that it's very important, and you see that the growth is quite tremendous. And those batteries, they will go, as I said, in automotive market, but they will go also in the robot humanoid. You start to hear about that, but that will be the major revolution that we will go through. I think that next year, if we have a meeting, we will talk more about robots than EV. But it's clear that the market will be there because reservoir of energy with all the new technology is needed. Of course, to support that, there is some a booster. I could list, 20, I would say, factors that will help to the battery to come and everything. But the major are very obvious. Sustainability. Sustainability is what? If we are coherent, we are trying to have a better world. All the time I'm trying to explain to the people, if you want to explain sustainability, you go to see small children and you explain what you do to them. You explain with simple words your company, and if they look at you and they say, wow, then you're good. Then you're good. It means what you are doing is something that will be very interesting for the future generation, and then you're good. Don't try to be a scientist and try to explain with a teraton of CO2 reduction of something doesn't mean anything. So that is very important. The other is we call electrification, but electrification, in fact, this is a big bulk of technology, big bulk. Hardware, software together that we need to handle. And that it's something that I would say that is evolving still today, and it will come even more and more, I would say, fine in the future. For the third point that I put there, it's tech and AI. Yes, of course, we have to have the machine learning. We need to have intelligence artificial around the battery, because most of the time, if you want to increase the lifetime of a battery and increase the safety, the software is more or less 20 to 30% of it, of the result. So it means that the hardware is not the only component to succeed. Of course, to stop the battery or EVs, there is many break. The same, I can list 20 of them. But this is the one that we are facing in every country. I have the chance to work on all the continents, and China included, especially China, and I can tell you that the mismatch of the demand is, I would say, more valid in Europe. Because today we say, what, the electrical cars are not taking off. But first, if you see the cars that are for sale today, you need to be very open to buy those cars because they are not very competitive and they are not very attractive. That's clear. We have to say it. Then, in the same time, we have the pressure. In Europe, if you look, how many batteries we are producing is quite nil, because everything is coming from China. But we have 90% of the regulations. 90% of regulations, of rules to apply and everything, but no battery. We are very good to create rules, but absolutely bad to do battery. That is clear. The other point is the supply chain. I was speaking about the mine. To make a plant of battery is 5 years, when you are very good. To open a mine is 15 years. If you are lucky, because everybody speaks about sustainability, we want electrical vehicle, clean car, but nobody wants a mine close to his place. If I tell you, near to your place, we have a big quantity of lithium, of cobalt, of nickel, and then we will come to extract it, do you think that you will be very happy of that? No. So there is this non-coherence between what we want to do and what we can do. That it's a break. And after there is the stress point. What I call the stress points is when you want to drive electrical vehicles when you are not used to, your question will be what will be the autonomy. If you are in winter somewhere, you will reduce by 2 and sometimes by 3 your autonomy. So you need to know. In the same time, you will think where I will plug my car. Of course, they will tell you, don't worry, you go to the screen and you click it and you will see it's working. For the one who tried, in many places you arrive, the charger is off or the charger is limited in time. They tell you that your car will charge in 15 minutes. In fact, you take 2 hours. And then the experience is not so good. That is clear. After, I will pass very quickly on that. It's regional. You know, I'm considering that, of course, there is the world is important, but you have 3 locations in the world for the business. One is North of America with US. The other is EU. The other is Asia, but I would say China. Okay. So, of course, every region are specific. We spoke today about the decoupling, political, geopolitical aspect and everything, of course, and also there is cultural aspect, how to do the business. So I will pass quickly on that because that you will have access to the presentation and see, and I want to go to the, I would say, how we are disruptive. First of all, we are there on talent, and I will insist on that. To succeed, you need to have talent. You need to have people that are crazy of what they do. They need to be brilliant, and they need to love what they do. If you don't have that, maybe you will do something, but I think that you will spend too many years to reach the success, and that will not be possible. So that is very important. So we have a company that is producing battery, I said, since many years. And when I say producing, if you come to our factory, we have robots, because the factory are highly robotized. You cannot touch that by hand, because the precision, the speed, the safety require robots. So when you come to our company, we have a lot of people in labs, a lot of engineers and doctors working in the labs. And in production, we have robots. Robots look after robots and robots. That's it. Because we need to be precise, we need to be quick. And also for safety purpose, we need to avoid to have humankind around. So that is clear. The other point is, this is one picture of one of the factory when you enter inside, but there is and it's carry on, and there is other factory. And I say that we have this experience since 14, 15 years today, but in fact, the story of our research started in 1980s. We spent 3 billion euro in research and development till today. And we are able to produce those batteries that you see on my back. Those batteries are fitting into buses, into trucks, into tractors in different countries in the world. The advantage, our battery don't use cooling system. We don't have cooling system. So no liquid around. You can make a plug-and-play system, what we call the swap system. And they are also not, the Gen 3 today are not using nickel nor cobalt. So they are just on LFP. So it's a lithium phosphate, ferrous phosphate. So that is very interesting as a technology, but it's limited till today because we are today with solid state at the top level of the lithium ion today. So now we have no technical age, except that our battery don't have cobalt and nickel, and then they don't need cooling system. But it's not enough. We need to go further. So to go further, we test them in bus, because also I'm the boss of a company that is equipping all the electrical bus in Paris, for example, and 70 cities in France. We have bus different size. We have design bus. We do the BMS, super BMS, the software. We put the battery. We run them for 1 million kilometers, and we learn what to do. And this is the best way to improve your battery, because we start from the design somewhere, and we test on the road with very harsh conditions, because believe me, the bus in the city like Paris, they are suffering a lot. So that we are doing. Now we have a strategy to move ahead, and the strategy is written there. You know, we need to be different. We need to create product that is different. We need to have a footprint that is different. We need to have also a business model that is more nimble, that is able to adapt to the market. And that it's linked to our battery, because it's very special solid-state battery, you know, and I will pass just there. Okay, it's a bit, I'm sorry, it starts to become a bit engineering, but very simple. What you see on one side, this is the battery that you have on your phone, okay? And the other side, this is a solid-state battery. Solid-state battery, First of all, for the same energy, you will have a smaller size, it will be lighter, and we are quite new, we are quite innovative because we are using lithium metal. You know, this is the only metal that is floating in the water. It's 0.5 in density, but it's very difficult to manipulate, but we have more than 200 years of, I would say, experience in extrusion in our company, and we are able to manipulate this lithium. Lithium of 20 micron. Your air are 50 micron. You cut in two, then you have more or less the thickness of the product we are able to produce to make battery. And we have developed also electrolyte, molecule by molecule in the past 5 years, and now we are scaling up in the big factory in France and in India, those products. And also we are able to develop a technology that is fully agnostic to the technology of the cathode. Then if a customer wants a very high energy, we will be able to use nickel cobalt. And if a customer wants less energy but cheaper product, then we will go to LFP. And that this is, you see one of the cell, okay? You know, this is more or less the shape. It could be different according to the applications. And that this is how you can foresee what will be the product. Here, this is the performance of our battery. Just keep in mind, today, the best of the battery in the world produced by CATL is nearly at 300 watt-hour per kilogram, the best. And this one is containing nickel and cobalt. So this is important to have that in mind. It means that for the same cell, we are able to offer 50% more autonomy to the best one. And after I tell you, the liquid battery, they arrive at the limit of the limit, because physics is physics. For the one that knows this table of chemistry, called Mendeleev table, you will not create new performance on element. You know, electron is electron. The speed of the electron is fixed. Sorry, we cannot change it. So that we are moving, that I will share with you, that's what is our plan, because we have a plan to develop ourselves in many continents, in many areas, and you will say, but how you do that? You go everywhere, you crazy? Yeah, of course, because I have a partner with me. In the past 2 years, we signed a lot of joint development agreement to be sure that the product we will offer will fit to the market and will be the right technology, and that we will have order intake at the right time with them. So this is some example. Sorry, you see the flag? Because some of them is extremely confidential. You could understand in the battery. We are like shakals, we are killing each other, so I cannot communicate on everything, but you have to know that it's developing. Next year, we will be maybe 12 partners, and it will carry on. So this battery that we are developing has different form factors, and is going for any kind of application. The target is to be able to produce a battery that will fit for everything. Why? Because today you have a market. Maybe you will have a customer that will order for a passenger car for 1 terawatt hour, and maybe the year after it will be 0.5. Then you need to compensate. The only way to be stable and to have volumes is to be able to work for every customers, every type of application. So also we have a concept of factory that is different than the others. Our factory is vertical and small and modular. And why it's modular? It's because we want to be sure that we will invest exactly, if we get a contract, we will make a tower. What we call a tower, it's a factory. And those factories will be able exactly to answer to the needs. And on top of that, we want to be coherent with our sustainability policy. We don't want to have a big factory where 50,000 employees are coming to work, because it's not human size. We were seeing those generation X, Y, Z, millennium and everything. You want to make them work in the factory of 50,000 people? No, it will not work. If you take the example of North World going to the north, Sweden is a beautiful country and Bo is there. And yes, but when you go to the North Pole, if you are not used to, it's very difficult to stay, right? Okay, so on top of that, when the factory is too big, people think that I'm not existing inside. I'm just a part of it, a little piece, and I'm not really. On top of that, it's proven that above 200 people somewhere, it's very difficult to know each other and to collaborate well. So we want to have a small plant because the equation is to be close to the customer, to be close to a reservoir of talent, to have a human-sized factory, and also to be able to invest less because behind any company you have shareholders, and when you go to see them and say, sir, I need 2 billion for a plant, it's very difficult to convince them. And nowadays, more than before. Oh, okay, you see the passion? So I didn't mention the gravity, because in fact, this is what I want to show, gravity. The tower will work with gravity, okay? So that's why we have towers, because we are managing the chemistry, and from the top to the down, we're using that. And we will use also the energy of the ground, because we need to be very stable in temperature for the precision. And the ground, you know, below 1 meter, you had 16 degrees C, very stable. And then you have just to put 4 degrees to make your production very stable. Summer, winter, whatever happen. So that is very important. And I will not jump again. Okay, so it was not planned. So anyway, and also we have a plan that will be very limited in people. Very limited. The operation will be extremely limited. I don't put there to not be you to be scared, but we will have a lot of humanoid robot inside to work to help our people there. And this is the approach that we have. Business model, completely open. If we have a customer that wants a tower with all the process, the technology, and he wants a license, then get it. I give it to you. If you want to make a joint venture, we do joint venture. If you want us to produce for you on standalone, we do it, okay? No big deal. But when we produce battery, we're all the time at the beginning of the design preparing the recycling, because we have a lithium metal. You know, lithium metal is very precious material, and the idea is to recycle. There is also big constraints everywhere in the world to the percentage of material you have to take. And then we are there today, and we are able to recycle today already 90% in our production. And that this is something we will really keep and go. Now to close the speech, everything is possible if you remain human-centric. If you think people. The failure of all these battery companies in the world is because they bring money, they bring technology, they bring the people, but they didn't think about the people inside, how they will live, how they will work, how you will handle them. And at the end, they fail. The main reason is that it's people. You are not people-centric. On top of that, we need to be coherent. We want to work for a better world, and you want to create a huge factory and put concrete on million square meters. This is absurd, okay? So we need to be coherent. And that, for me, this is very important. And to succeed, we need partner, because the vertical integration is the major mistake today. Vertical integration is very attractive when you are at the CEO position. You want to do everything yourself. Let's open a mine. Let's make the refining of the material. Let's produce the cathode, electrode. Let's make the assembly. Let's make the vehicles. We stop that. The development will be horizontal. We will be good in what we do, be expert, and for all the other components, we will work with the best in the earth. That's why we have signed a lot of GDA. And I will not go further, because after you will have a headache on my talk. But the point is, I want you to know that it's, keep in mind, whatever we speak today, the success will come if we are frugal, but first we have to be human. If we are human, we will succeed. Thank you.
Thank you, Richard. This was an absolutely amazing presentation. I'm super interested in the vertical integration part. I've never seen that before. Okay. I'm involved in a company in Slovakia, maybe you might know them, Innovat. We're working with modular systems, but not vertical, so I would love to hear about that later on.
With pleasure.
Thank you very much.
Thank you.